Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we are solving a question that is related with trigonometry and integration. This is from May June 2019, variant 33, and this is question number 3. Now the first part, this is about proving a trigonometric proof, and the second part, that is about integration. So let's get started with this. Now 3 marks are for the proof. Now look at the numerator. I want you to focus on the numerator first. 1 minus, and let me just make it shorter, 1 minus cosine 2 theta plus sine 2 theta. I should expand this separately, and over here 1 plus cosine 2 theta plus sine theta. I should expand this separately. So let's work it out very thoroughly. 1 minus cosine 2 theta plus sine 2 theta. And over here 1 plus cosine 2 theta plus sine theta. Sine 2 theta. So now what exactly needs to be done? So let me draw a box over here and let me write all the different double angle formulas that I'll be using. So the first thing is sine 2a or sine 2 theta, that is equals to 2 sine theta cosine theta. It's good that there are no options in this one. But when we talk about cosine 2 theta, there are 3 options. The first one is cos square theta minus sine square theta. The second option is 2 cos square theta minus 1. The third option is 1 minus 2 sine square theta. Now I have to decide which one is relevant over here and which one of the expanded form is relevant over here. Now my rule is very simple. That is, if there is a plus before and there is a negative sign and I'm focusing on cosine 2 theta, I should choose the one that should minimize my work. So my focus is on minimization of work. So if I write this one over here, this minus will cancel with this one. So over here, the red one, that is for this thing. So I'll choose this one over here, and based upon the same thing, I'll choose this one over here. So let me write it down. 1 minus and cosine 2 theta plus sine 2 theta, which is 2 sine theta cosine theta. So now over here, if I write 1 minus 2 sine square theta. And over here, let me first write it, 1 plus cosine 2 theta plus sine 2 theta, which is 2 sine theta cosine theta. And what exactly am I writing over here? This thing, that is 2 cosine square theta minus 1. 2, let me choose a blue marker. This is 2 cosine square theta minus 1. So now what happens is that this one and this one cancels out. This negative becomes positive. So this is 2 sine square theta plus 2 sine theta cosine theta. Over here, what is going to happen is that this one and this one will cancel out. Plus sign is already there. This is 2 cos square theta plus 2 sine theta cosine theta. Now, is there anything that you can take common? Of course you can. So let me take common 2. Let me take common sine theta. I'm left with sine theta on the inside, and I'm left with cosine theta. Similarly, over here, if I take 2 cos square theta, I'll just take 2 cos theta common out. I'm left with cos theta plus sine theta. Not a bad idea to double check. 2 cos theta, cos square theta, 2 cos theta, sine theta, 2 sine theta, cos theta. That is good. And over here, I have 2. And this is sine theta, sine square theta, 2 sine theta, cos theta, that is 2 sine theta, cos theta. So now this is the numerator and this is the denominator. And let's just divide. So now numerator over denominator, this is 2 sine theta bracket sine theta plus cosine theta. This is being divided by 2 cos theta bracket cos theta plus sine theta. So now these two things are the same. it cancels out. The 2 cancels out with the 2. Sine over cos s, tangent theta, quite easily done. And that is how I have obtained the 3 marks from here. So it looked a bit scary, but with wise thinking, you get your answer in the shortest possible time. That is what I'm here for. The content that I produce, it's to make sure that you get the basic knowledge of maths, no compromise on the authenticity, but at the same time in the shortest possible, most precise way. So now let's move to the second one. Hence show that the function, when we integrate it between these two limits, should be half ln 3 over 2. So f theta, we have already proven that f of theta is tangent of theta, d theta, lower limit pi by 6, upper limit pi by 4. Now what exactly do we need? So now we need this thing. What is the technique that we need to apply? So integration technique, that is if the numerator is the derivative of the denominator, and if we integrate such a fraction, that is ln of the denominator plus a constant of integration c. But if there are limits, there are no constants because that's definite integral. So this is sine theta over cosine theta d theta between the two limits pi by 6 and pi by 4. So lower limit is pi by 6, upper limit is pi by 4, all good. Now we should also know that derivative of cosine theta, d by d theta of cosine theta is negative sine theta. That means the negative is missing over here. That means if we want the numerator to be derivative of denominator, what is the missing link? That is the negative sign. In order to balance it, there should be a negative on the outside. Now this thing looks exactly of this format. So therefore, I'll write negative ln cosine theta, and the limits are pi by 6 and pi by 4. Now, as usual, it's a favorite idea of the examiner to test with a negative sign. If I remove this negative sign, I can flip the limits. So this is ln cosine theta between the limits. Pi by 4 goes down, pi by 6 goes up. Another thing that I want to focus is this thing, that we know that we are dealing with cosine and the integration is already done. So cosine of pi by 4, that is root 2 over 2. And cosine of pi by 6, that is root 3 over 2. So I'll be using these two. So let me first plug in pi by 6, that is ln and cosine of pi by 6. And then let me plug in pi by 4, that is ln cosine of pi by 4. And there is a negative sign in the middle. So now cosine of pi by 6, that is root 3 over 2. And ln is there. Minus ln cosine of pi by 4, that is root 2 over 2. So what about the third thing? So let me also bring that in. So all this knowledge is used. That is log x over y base a, that is log x base a minus log y base a, and it can go both ways. This equals to this equals to this. So there is a negative sign, therefore I should divide. So therefore ln root 3 over 2 divided by root 2 over 2, that is ln root 3 over 2 into 2 over root 2. Therefore this is ln root 3 over root 2. But wait a minute. There is also another rule of log, and let me write it over here. That is our log x power m base a can be written as m log x base a. That means I can use this power and make it jump on the outside. So what I can do is that let me write ln 3 over 2 raised to power of half. So I can first write this thing like this, and then I can write it like this. That's what I've written. Now make the power jump according to rule of log. So this is half ln 3 over 2. Now it's a good time to check the answer. Half ln 3 over 2. So a star for myself. and that is from Mathematics with Shahab Yaqub. So we have solved this particular question. We went over the rules of log, we went over integration technique, that is this particular one, that's right over here. We went over the exact values. So every single thing that you have learned in P1 and naturally in P3, that is used over here. And we have done a trig ID. We have used double angle formula. We learned which is the right option that we need to use. And that's all from my side. So work hard, and that's how have concept clarity in totality. So that is how you will be able to score your A grade. Take care.